Welcome to Lecture 3 on transport. It's pretty obvious that you can't crack climate change if you don't crack transport, just as you must crack electricity generation and energy, and you must crack agriculture. Now, transport is probably about a quarter of the total carbon emissions, and almost the entire transport sector is focused on the internal combustion engine. Diesel and petrol engines have literally driven, the great industrialization of the 20th century, and almost everyone around the world aspires to have cars when they reach a particular level of income. So all those millions of people in China, India and Africa who are gradually getting towards the threshold where they can afford to buy cars are going to do it. So we basically have to imagine by 2050 a world without internal combustion engines, or to the extent that it has any left at all, that all the emissions from the internal combustion engines are sequestrated back through natural sequestration, soils and trees, etc., or through CCS. So it is one hell of a challenge to take a transport system and make that transformation. And cars, trucks, vans, etc., are at the heart of this. I'll come to shipping, aviation, and public transport a bit further down the track. So how do you do that? Well, the answer is mainly that you have to electrify transport, but you might also do some hydrogen, which I'll come to also in a bit. So electrifying transport means a complete shift in the way in which energy is delivered through vehicles to give us the transport we need. Electrification means essentially batteries. And we have batteries that work, that do the job. Indeed, if you go back to the end of the 19th century, the electric car got there first before the internal combustion engine. So it isn't as if we lack batteries. What we lack is batteries which are sufficiently efficient and sufficiently light and have sufficient charging capabilities over so they can run for long durations and therefore do long distances. We lack those components which make electric transport cost competitive with our internal combustion engine. And recall, as I've mentioned in earlier lectures, that the internal combustion engine means of transport is probably going to get cheaper over time because it's very likely the oil price will fall over time as decarbonisation more generally takes place. So, batteries. We have essentially the lithium-ion battery as the core one that almost all the car firms in the world are pursuing. Why? Well, because we have it. It's not that old. It's only a few decades since lithium-ion batteries were invented, but we've had billions or millions at least put into developing these primarily for the computing industry. So your phone, your laptop, these are all with lithium-ion batteries, very small ones. What we need here is large batteries for cars to do these distances. So batteries might advance. We're probably going to get next generation technology to displace the lithium-ion battery, but we're kind of stuck with it for the moment. So with those batteries, what really matters from the net zero perspective is not only getting them into cars and getting people into electric cars as opposed to internal combustion engine ones, but it's all about charging. How exactly are you going to charge millions of batteries over time? Now, there is a pretty straightforward way of thinking about this problem, and as with many of these things, corporate interests and rational calculation for self-interested reasons produce an answer which is not exactly optimum. So if you wanted to have a means of charging batteries quickly, you wouldn't go and drive to a station and plug in a cable and go and sit and have a cup of tea for a half an hour in a grisly motorway service station. You'd simply drive up into the station and somebody would do effectively a pit stop for you, whip out the battery in your car, put another battery in place, and out you drive. It's not quite a Formula One pit stop, but it's pretty damn quick. It should take a few seconds, maximum a minute or so, to switch one battery to another. And imagine that you could have all those decharged batteries being collected. They could be charged at night when electricity is cheaper, and then they could be stockpiled at the garage, and you just keep going. And you just lease the battery for your car. Eminently sensible way of doing it. Best way to optimise the electricity system to do the charging, and I'll come on to that in a moment, and the one that is not taken. It's the path not taken. Why not? Well, because each car manufacturer sees their battery as being a way of having competitive advantage. There is no interest amongst the large car producers in sharing the technology and standardising it. And for that reason, every car manufacturer is developing its own batteries, and the substitution between those batteries is basically non-existent, and the consequence is we now have to charge each car individually so that that individual car can provide the services that people want from it. And that in turn requires a whole network to support it. Now, when you go to the motorway service station, I suspect, like me, your objective is, apart from using the conveniences, to get in and get out as fast as possible from places which can be pretty grim. You go in, you put the nozzle in, you fill up the car, you drive out as soon as you've paid. Well, if you want to do that with an electric vehicle and the battery, you have to have really fast charging, and you have to have instantaneous fast charging, and that means that the infrastructure has to provide that electricity to you at the time you want it, which is almost certainly going to be peak time. It's unlikely you're going to be doing a lot of fast charging in the middle of the night, because hopefully you're asleep, and that's not what you want to do. So if you want instant charging at the existing network of stations, we have to have a system, a grid, and a distribution set of networks that are actually capable of doing that instantaneously or over a matter of a few minutes. That's a huge infrastructure ask, because the electricity grid and the networks are not designed to have essentially the road system and the service stations as core takeoff points. So if that's what we want, and if that's what we demand, then the investment requirement to decarbonise is going to be much, much higher in networks, and that's going to cost you. And the fact it's going to cost you means that you need an even bigger incentive to get out of your cheaper and very reliable fossil fuel driven internal combustion engine. So if that's what you want, it's going to be pretty expensive. Now, hopefully, the tariff structure will steer you towards going home in the evening, plugging in the car and letting it charge overnight. This is a completely different proposition. You get home, 8, 9 o'clock, you plug the car into your household electricity supply or into the street, and all you're interested in is when you go to work at 7 the next morning, the car is charged up. Then the system can be really smart. So at night, demand for power is lower, so we can use spare wind capacity. Can't use solar, of course, and we can use the generation on the system, and it's going to be relatively low cost. And what's more, we can use it spread out over time. As long as it's done by 7 a.m, it's fine. And that means that you need very little new capacity on the system in terms of new generation. You can just use the system more efficiently. It's a kind of evening out of the demand profile for electricity. So if you charge at night and you're willing to be flexible, completely different requirement. And that's all about the distribution networks and how the distribution networks are going to be able to cope with your house maybe having solar panels on the roof, with your house having electric heating, your house having smart appliances, and having all the usual demands that you in the household will want with your appliances and so on and so forth. Okay, so it's about ramping up the bottom of the electricity system networks, not the higher voltage systems which might be required for motorway service stations. So that's perfectly plausible, but it's a huge investment. And here's the question: who's responsible, not just for making the investment, but for ensuring the security of supply in those distribution networks, and indeed at the grid level? And the answer to that is it must be the duty of a system operator to ensure that the network's in place, the supplies are available, so that the charging works in a seamless way, preferably overnight. And that's really picks up on a core feature of the cost of energy review I did some time back, which is all about having independent regional system operators and an independent national system operator which sets the requirements, which then the networks, own generation, renewables, demand-side measures, storage, etc., can all match together. So electric cars, doable, but they're really very much about having an electricity charging system which is up to the new demands that are required. And most people sort of look at the electricity system, take it as it is, and they just plug in the requirement for charging vehicles and say, well, that'll do the job. We've got enough space. But they don't remember there's going to be lots of other additional demands on that electricity system, as well as the extra demands for transport. So if you're going to do a lot of electric heating, if you're going to have a huge amount of digital developments, quantum computing requires a huge amount of energy to provide the right temperatures for the systems, Bitcoin, all of these things are going to add to electricity demand as well as the transport. And that requires a really serious redevelopment of our networks and our electricity systems around system operators to deliver. Now, there's one other way we might do it, and that's hydrogen and fuel cells. And of course, what really matters is how the hydrogen is generated in the first place, and that's a function of whether it's done from reformulating natural gas, so it's a fossil fuel-based system, or whether it's harvesting excess renewables, particularly excess wind, converting it into things like ammonia and then turning out the fuel cells. It's not at all clear that that's going to work particularly well for cars, etc. But where hydrogen becomes incredibly important is when we start to think about the other demands for decarbonisation of the transport sector. Because, of course, transport is about cars, and fossil fuels back those cars, but it's also about aviation, shipping, and public transport. And when we look at these other alternatives, on the shipping side, what we have to have in mind is just how fantastically polluting global shipping trade is. Much of shipping uses the dirtiest fuels because they're cheapest. The emissions are, to date, largely out of control in the sense of being international trade. The remit of the relevant governments is pretty limited. And of course, the main shipping players, countries like China, increasingly India and the Middle East, America, all of them are basically outside the formal framework of what's required to do the 2 degrees maximum temperature increases. So what do you do about shipping? Well, part of that answer might be to use hydrogen, and there are really interesting and exciting developments of thinking about hydrogen storage for shipping and taking that forward. But the blunt truth about net zero, and net zero thought of both from the point of view of a particular country, Britain, the UK, and also from a global perspective, is that it's pretty hard to envisage any world in which shipping carries on growing on the scale and level it's growing and we meet the 2 degrees target. This really is a question about whether we should be thinking about reducing our demand for shipping and therefore reducing the amount of trade. This all comes back to the point about carbon consumption. When you go and buy those imports, which are excluded from the domestic net zero target, you're not only buying the carbon embedded in the steel, the cement, the fertilizers, the aluminium, the petrochemicals as well, but you're buying all those emissions to get those things to you on top of that. And that means that when you really think about the carbon border adjustment for shipped items, the costs are going to be much higher, and if we were to confront those costs with the appropriate carbon price, we'd do a lot less trade. That is an important part. And think also about your own consumption. You may go on a cruise ship. Have you ever thought of how polluting cruise ships are? Almost everything about taking a long distance cruise, going up to see the Arctic, going around the Caribbean, represents really quite gross carbon emissions. And woe betide if you sit in a port where one of these cruise ships is running its engines on pretty poor quality bunker fuel in order to run its electricity systems and everything on board the ship. So again, if you really paid when you bought a cruise ship ticket the pollution that's being caused, you probably should think again. And aviation has the same kinds of characteristics of shipping. You can envisage a net zero shipping and you can envisage a net zero aviation. But it's pretty hard once you envisage it to think much of that's going to happen quickly enough to keep to the 2 degrees and meet net zero targets by 2050. Aviation is inherently polluting, and because it's up in the atmosphere too, it's more polluting than the stuff on the ground. And so, yes, we have to bear down upon the emissions from planes. Technology will help on that as well. Of course, there are prototypes of solar planes, battery planes, and so on, maybe even hydrogen planes, but these things are a long way off being the everyday means of transport that we've come to depend upon. You can offset the emissions, and natural sequestration and CCS is essential in this world to do so. You can raise the price of airline tickets to reflect the carbon, but add all that lot together and it probably still is inconsistent with our overall targets. You know, a huge number of people now think that it is perfectly straightforward to take at least one holiday by aviation, by flights per year, and lots of people think it's perfectly normal to fly several times a year. Some people even think that going by private jet's a good idea and that they're entitled to do that, and as with our royal family, at the same time lecture the rest of us about how we must address climate change. Now, aviation and shipping will probably have to have their demands reduced if there's any chance of getting to our net zero. And there's really no way around that. And if you look at the speed of airport development, even here in the developments with regard to Heathrow, you know, the one airport a week in China added to the system, the large number of people in developing countries who now want to take up aviation. This is a huge problem to any serious net zero and requires an enormous amount of offsetting. And that brings us to the final option, which is public transport in the forms of trains and buses and trams and so on. You know, why do we have to have our own individual cars? Why do we have to go on short-haul flights when we can go by trains, which can be decarbonised using electricity, etc.? All of these things have great benefits, and the reason we don't use the trains and the reason we don't use the buses, that's the vast bulk of the population. We don't go by train, most of us. The reason we go in the cars is because they're convenient and they're a lot cheaper when you add all the features together in terms of comfort, flexibility, immediacy, etc., than the public alternatives. If you want to do net zero in transport, at least domestically, you have to have a major shift from private car-based transport to public transport. It's been tried for a long time to make that substitution. In 2000, John Prescott famously wanted to have a 50% switch and promised to resign if he didn't achieve it within his term of office covering transport. Of course, he didn't achieve it and he didn't resign, but then that's politicians. But the reality is this requires infrastructure planning too. It requires powerful local authorities, powerful transport authorities, and yes, significant public transport subsidy to make this substitution and a realistic and true price for the costs of private transport. You know, do all this, electrify vehicles, substitute from the internal combustion engine, bear down on shipping, bear down on aviation, invest in public transport, and build the electricity infrastructure to do it, and then we're making progress, and with it, a border carbon adjustment to deal with those shipping imports on top. It's a big ask, but that's what you'd have to do if you really wanted to achieve net zero for the transport sector. And next I'll turn to agriculture, where the challenges are, if not equally as great, large and largely under thought through. Thank you very much.